Now, if you were in class today, we got a chance to start talking a little bit about two-step conversions. Now, there are a couple of reasons why we want to have something like a two-step conversion. Since we've started, we've talked about mole particle conversions or mole gram or even mole volume conversions. But in no way when we did that did we talk about something that would take us directly from molecules to grams. And that's where we actually need to work. That's how our reactions will actually be set up. So let's take a little bit of time and go through the process of what we're going to do to get there. Now, these are some of the things that we know and we're walking into as we go. Now, if I'm going between atoms and molecules and grams, we know that 1 mole of any substance, especially of certain particles, is 6.02 times 10 to the 23rd particles. And 1 mole equals the molar mass in grams. We can use both of these conversion factors to get to grams or get back to molecules. But we cannot go directly. We have to go through moles. So, let's look at an example. Or look at a chart. You see everything flashing. Everything must go directly through moles. So if I'm starting in grams, I'm going to utilize my molar mass that I calculate for that substance, whatever it is, to get to moles. And then afterwards, I'm going to use my Avogadro's number in order to go the rest of the way. Let's use this next example. Now, how many atoms of copper are present in 35.4 grams of copper? Our given here is actually going to be our 35.4 grams of copper. Now, if you think back to the slide we just went through, we know that the next piece that we need is our molar mass. So we have to set up our conversion factor accordingly. We're going to have our 63.55 grams, which we take from our periodic table, and it goes to the bottom, so we'll be able to actually cancel out our units. So our grams of copper will cancel out in both cases. Now, this leaves us in moles, but our final answer is to be in atoms. So we want to take a little bit of time, got one more step to go, and we're going to bring our 1 mole of copper down, and now we have to multiply by our Avogadro's number, 6.02 times 10 to the 23rd. Now, for most of you, it seems like it's an easier thing to do this, to go ahead and multiply the numbers on the top, multiply the ones on the bottom, and then divide at the end to get your final answer. If that is your preference, go ahead and make sure you take the time to do that. I have no problems there. I myself will actually use a pattern where I will multiply, or I will divide by this first, and then multiply it by our 6.02 times 10 to the 23rd. Either way, you should come out with the same answer. Our final answer in this case is going to be, once it pops up on the screen, our final answer is 3.4 times 10 to the 23rd atoms of copper. So, when we look at, even though it seems like it's not really that much copper, that many grams of copper, there are so many atoms packed into that small sample. And this is where we can continue to look at things on a microscopic level based on what's happening at a macroscopic level, or what we can see versus the things that we can't see. Now, on your own, we have a question for you to try. How many atoms of potassium are present in 78.4 grams of potassium? Take a few moments and look over this tonight. When we come in on Tuesday, you'll have the opportunity to go through more examples like this, and then we actually have a comprehension check coming. Have a great weekend, and I'll see you on Tuesday.